So first is in musical construction kits. Again, I've been doing a lot of work collaborating with Eric Rosenbaum at the MIT Media Lab, and this was a spin-off of one of his groups. This is the Makey Makey. You might have seen the video online, but it's designed to look like an old school Nintendo controller. You have your up, down, left, right, space with this. But all it is it's a customized version of an Arduino microcontroller with high resistance pull-up resistors in it. And it's designed to mimic a computer keyboard and mouse. So when I plug it in via USB, the computer just sees this as a QWERTY keyboard with this. But the cool thing with it is that we can then work with any piece of music software that receives keys and then interface the physical world to that. So to give you an example of one of the first projects that I do with kids is to interface this to music. So I have one connected here. And the Makey Makey comes in a nice little box like this with alligator clips and things like that. So I've just connected a bunch of these here. So I need some volunteers, I think. Let me just make sure we got some. Yeah, we got some. So maybe Finn, you would like to grab one of these? So yeah, hold the metal part. It's not going to shock. Okay. So we now have that. And this strip on the bottom here is electrical ground. So if I hold on to ground, take your other hand and put it in the middle. You don't have to touch it. Just put it out in free space. Oh, closer to me. Right. Now, I can touch her to create that, or you can touch her. Right. And so we can build human drum sets. And this is what we do with kids to start off with. There you are. And we need a couple more volunteers. Oh, are you moving around? Move your feet. Occasionally we get static from that, so sometimes you have to stand by yourself and stand still. So there you are. And now take your free hand and put it in the middle. And now, or you can play me. You can't play each other. Why can't you play each other? It doesn't complete the circuit.
Can you do dynamics like hit someone hard?
This is not dynamics. This is just triggering. Yes. Yeah. All right. Thank you very much. Yeah. So, yes, you can give them a hand. But very simply here, with this, the kit itself, the Makey Makey is at $49 with that. But it's nothing you couldn't do with an Arduino. It's just been, packaged at a higher level to make it easier for kids and teachers to work with. But the way that we have it set up here is I just have it connected to Scratch is now web-based and runs completely in the browser. You don't have to download it. And so here it's running as a web app. And what I can do is I can click C inside, and now I get access to, I'll make this bigger, to the code that I use to map that. And in Scratch it ends up being very simple. So if you look here at the top, the very top set of code right here, you have an orange block which says when up arrow key pressed. Then you have a block below it which says play drum 1 for 0.25 beats. So I can go here on the keyboard and press the up arrow. Or, because this sends keystrokes, I can then hold ground and press the up arrow virtually. So we work with kids with using conductive string, foil, all sorts of interesting kinds of conductive materials, graphite with pencils, designing their own instruments, putting this together. And in Scratch, we can click over here on sound, and you get all of the music and sound blocks. I could swap out that drum sound if I wanted with a MIDI note. So here it's play note 60. I get a middle C. Or I could play a recording. So I could import samples. I could just use the new built-in sound recorder within Scratch and put in a phrase, tell a digital story, any kind of thing working with that to work. But as you can see, this is the default set of music blocks and sound blocks within Scratch. If you were to build up a musical sequence in here, you have to work at a pretty low level. You have to work at the level of the individual rest, note, drum sound, and things. And so when you're in a novice environment with that, it takes a lot of musical understanding and prior computational experience even to be able to build up an interesting piece of music. And so one thing I'll talk about a little bit later is are some custom blocks that we're designing so that here, it's nice, you can do a one-to-one mapping of a note, but wouldn't it be cool if you could more easily map it onto a musical phrase or map it onto a chord progression? And if you were to build that functionality here just out of these blocks, it might take you 9 to 30 blocks to do that. So what we've been doing is taking advantage of a new feature within Scratch where you can build your own blocks to bring that together in procedures. So this is one of those areas that we're working with. The other area that we're working in, I'll try and zoom back in here, is working with a startup out of Cambridge in the UK called Novalia. And there was a recent TED Talk on paper-based DJ decks that was on TED. I don't know if you've seen that. You might, I'm going to flip this. And I have a beta with me here. What that company focuses on is in using conductive ink printing and wireless Bluetooth. So what I have here is just just a mock-up of a switchboard with 8 different pads on it with foam core. There's this very thin board here that we actually now have about half this size. We have it down to this, but it's a battery, it's an Arduino basically, and a Bluetooth chip. And it's functioning here. And on the back here, but you can't see it, is just, you have a regular sheet of paper here, and on the back has been printed conductive ink traces, which are then just spray adhered onto the controller. So what I have set up here is an iPhone app with a musical multitrack on it. And so if I touch here, you should be getting set up there. You just touch this and add another layer. So it's basically, pressing this is muting the individual tracks and stems of the multitrack. But what this allows us to do is that the paper and the ink is about 15 cents worth, and the wireless Bluetooth is about $2 now. So we're now able to get very inexpensive musical controllers. And so what we're going to be doing over the next year is prototyping a bunch of different music controllers for kids that are very inexpensive and that are paper-based. So we can use this to develop custom MIDI controllers, drum sets, things like that. So imagine you get your theory textbook, and in the back of it is a perforated little computer keyboard, and you just tear it out, you download the app on your smartphone, plug in an earbud, and then you can play along in your theory class exploring those chords that are being talked about. Or we publish a book of musical instruments where you tear out a drum set, or you tear out a MIDI keyboard, or a guitar, or a bass, and then you sit around with your friends and plug in headphones, and then you can jam together. So it's not just designing kind of existing things, but designing prototype kits. We can actually do multi-touch and multi-touch tracking with the capacitive touch with this. So again, you have more the makey, which is for building and kind of prototyping, and here is another higher level of abstraction using similar kinds of technology with that. But again, taking advantage of Bluetooth and multi-tracks as a way of engaging kids within their music. The other final thing that's kind of that's starting with the makey room is because there's so many people doing music-related stuff with the makey, we're developing a MIDI version of the makey with a dual keyboard layout, with a keyboard at the top and a keyboard at the bottom, where you're still able to plug into, I think, 3 octaves worth of notes. And it will have a switch on it where you can put it either into QWERTY keyboard mode or right into MIDI, so that you can very easily start to prototype MIDI triggers and controllers into Ableton, into whatever you're working with sound. So this is just a growing kind of area where we're focused on developing construction kits and environments for kids to play with their music.